Hi guys, welcome to our fifth and final video for chapter 11. This video is going to talk about the formula for a hydrate. So hydrates are a specific type of chemical that we haven't talked about yet, though we have actually used a couple of them in lab. So the definition of a hydrate is simply a compound that has a specific number of water molecules bound to its atoms. It is not dissolved. A hydrate is actually a solid substance that has water like embedded into its structure. So if we look at this example here, I have an anhydrous salt, the word anhydrous meaning without water. And then I have that salt, for comparison, I have a hydrate right next to it. And you can see with the anhydrous salt, it's just an ionic compound like we've seen before, alternating positive, negative ions. When you look at that hydrate, you can see they're kind of small, but you can see in the crystal, there are actually water molecules between the ions. Okay, so this is a very common type of substance, and actually a really cool example is opal. So this is a precious, I believe it's a mineral. You have to ask your earth science teacher about that one specifically though, but I believe it's a mineral. It's a silicon dioxide hydrate crystal. So I have it here. You can see it's very beautiful, very pretty colors. And a lot of hydrates, especially even the ones we have in lab, they change colors when they go from being the hydrate to the anhydrous salt, and it's very cool, very visual. Yeah, again, we can do some in class. They're pretty fun. So let's talk about how we can name these things. It's not the most complicated naming mechanism, right? So in the formula for a hydrate, the number of water molecules associated with each formula unit of the compound is written following a dot. And I'll make this a little bigger so you can see. But I have an example of our hydrates right here. So in our formulas, you can see, for example, in our calcium chloride dihydrate, you can see you have your anhydrous salt, the CaCl2, then a little dot, and then H2O, right? And then water. So again, same for all of these. You can see you have your formula, dot, and then your water molecules. Okay. So of course, you're seeing this table and you're seeing something else. And that is that when you name the hydrate, you want to give the name of the species, then add a prefix dash hydrate. So for example, if you have one single water molecule, just one water, like in our first example, you would call that aluminum oxalate monohydrate. So it's just the same prefixes you would use for a covalent compound, except now it's used for the hydrate, right? So if we look at 7, the prefix being hepta, we have our MgSO4.7H2O. That is cool. You have magnesium sulfate heptahydrate. Okay, so use this table. This is going to be something, well, use these prefixes. This is going to be something that comes up occasionally. It's not super important that you memorize all these things, as long as you are aware of what those prefixes mean, and that you should have a dot between your formula and your water molecules. So let's talk about how we would actually analyze this, right? So what do we do with these hydrates to actually characterize what their chemicals look like? Well, the most important thing you're going to have to do is heat it up, right? So to analyze hydrates, you got to drive off the water of hydration. And this is done actually very easily by heating the substance. You all know water has a fairly low boiling point compared to other substances, inorganic substances, water being inorganic. But yeah, so we can heat it up, we can drive off the water. And I have a very cool example here. And this is, you can see visually your hydrated cobalt 2 chloride, on the left. This one is pink. And so before you heat it up, it's all pink. It looks cool. Then after they heat it up, it goes anhydrous, meaning the water is gone. And when it's anhydrous, it is blue. So a very dramatic color change here is very cool. This is very common for hydrates. Okay. And once you've driven off that water, you can calculate the mole ratio of water to the anhydrous salt in order to actually give the formula for your hydrate. So I think that it's best if we actually look through an example here, and you can see exactly what I'm talking about. So let's say for our example, we've got a 5.00 gram sample of some hydrate of barium chloride. So I'm going to highlight some important information here. You know the formula to be BaCl2, not CO, but Cl2, dot some number of H2O, where X is our coefficient of the H2O in the chemical formula, right? So we don't know how many water molecules we have associated with our barium chloride ions. After you heat the substance, The remaining solid has a mass of 4.26 grams. Question asks for you to solve for X and give the formula of the hydrate. Right off the bat, I'm going to look at my numbers and say, okay, my answer is going to need 3 sig figs because both of my given informations have 3 sig figs. Very cool. And so let's think about what we did here. We drove the water off from our solid, and now we've got to figure out how much water we had there. So a good thing for us to do is to figure out exactly how much water we lost. So we'll begin by taking my 5.00 grams of barium chloride hydrate. So I'll say BaCl2 hydrate because we don't know the real formula. And I'm going to subtract off the mass of the remaining solid. And that's going to be my 4.26 grams of, we say barium chloride, right? That's what's left, BaCl2. And so if I do that, I'm going to get 0.74. The unit is grams. And conceptually, if I started with the hydrate, and if I'm left with just the inorganic salt, the difference in those weights is going to be the mass of the water. So that is 0.74 grams of water. So our initial step is, of course, to calculate how much water we actually had in our total sample. Now, we're going to convert both the mass of our remaining barium chloride and that water into moles, because we can then set up a mole ratio and see exactly how many particles of water we have compared to our particles of barium chloride. Okay, so I will take my 4.26 grams of barium chloride, 26 grams of BaCl2, and I'm going to convert that into moles. I know that in barium chloride is a 1 mole of barium chloride has a mass of 208.23 grams, 23 grams. And I'm going to include my unit for the identity of the species in this calculation. Cool. So my grams of barium chloride will cancel, times 1 divided by 208, and my answer will be 0.0205 mole of barium chloride. Okay, great start. Now I'm going to do the exact same analysis for my water. I'm going to take my 0.74 grams of water. I'm going to multiply that by 1 mole of water over 18.02 grams of water. And I see again, units are going to cancel. Excellent. Grams of water cancels. I'll be left with moles of water. And if I do my math for this, I'm going to end with 0.041 mole of water. Okay. So hard part's over. Now we've got to set this into a ratio. Okay. And so if I can do this a couple of different ways. I can take my smaller number, that 0.0205, and I can divide both numbers by that smallest number, right? So give myself a little bit more space before the end here. But so I'll make a note, like set moles in a ratio. Okay, so I can take my 0.025 205. Actually, let's set it up. I'll show you an alternative way. Let's set it up in a fraction so you can see how this works like mathematically, just an alternative way. I think it's a little easier actually. I'm going to take these two numbers and just set them in a ratio. So I'm going to take my bigger number and put it on top because I like to have whole numbers, not decimals. So I'll take my 0.041 mole of H2O, and I'll set that over 0.0205 mole of barium chloride. Well, in my calculator, if I do 0.041 divided by 0.0205, I'm going to get an answer of 2, which if you, and of course 2.0, because we have 2 sig figs in our given information for water here. And of course, if you have a whole number that can be expressed as a fraction as 2 over 1, right? So remember that from your math class. So 1.00 and 1.0. And we have moles of water for every 1 mole of barium chloride. So I've said that for every 1 BaCl2 I will have 2 moles of water. Excellent. So I could say like x equals 2 then, which means my formula, therefore, is formula equals BaCl2 dot, we have 2 H2O And my name would be barium chloride dihydrate. And that would be this would be my answers here for what the formula is with that coefficient and what the name would be for the species. All right, guys, that's all I have for this video. Thank you guys for listening, and I will see you guys in the next one.